Good.
Ready to go? So my little intro is that in addition to the excitement of using these online telescopes, we're big believers in hands-on demonstrations as well. And because you're introducing the kids to telescopes in this kind of remote way, we also want to make it very concrete. So we have a couple of little demos that are about just kind of how telescopes work and what you can expect to see through them. And whether you have your eyeball at the eyepiece or you have a detector there instead of an eyepiece. So either way, you're getting either a picture on your eye or a picture on that CCD detector, on that digital detector. There's some of the specifics of the telescope will determine what you actually see. So these are very simple things that were designed, demonstrations that were designed for amateur astronomers, because when they do their outreach at star parties, inevitably the question comes up, how does this thing work? You know, how do telescopes work? And Sue Ann featured a great little animation in her presentation last week that showed light rays coming down and bouncing around and going off to a detector and being interpreted by a computer. And that was, I think those are always great to watch that, but there's also some demonstrations that you can do that are a little more hands-on than that. And Sue Ann, I haven't asked you if you've shipped the toolkit materials yet.
They are, I should turn my webcam around so you guys can see all these boxes in my office. So
okay. So the things, the little bits that I'm going to be showing you are things that you will actually be receiving in the mail soon. And when you, whoops, there we go. So regardless of the style of telescope that we're talking about, this one is called a Dobsonian style. It has an open tube. A lot of the Dobsonians just look like big cannons. They're a solid kind of cardboard tube. Or this is a Newtonian. This is a Cassegrain. All three of these have different kinds of mounts, but they all use mirrors. Okay, so there's some subtle differences between them, but the idea is that there's this big mirror at the back of the telescope that is gathering the light, collecting the light. That mirror is not unlike a spoon. And we were actually going to ask you to grab a soup spoon for this little web chat. Because a spoon is a great way to explain what is going on. If you take a look in the back of the spoon, you see yourself, and it's a bit like a funhouse mirror. If you look in the bowl of the spoon, you look a little bit different. Your image has flipped. So in both of them, you look a little distorted like a funhouse mirror. And the goal with telescope mirrors is to not have that funhouse look, but to get a nice, sharp, undistorted view. And what I'm going to do now is point my camera down to my desk. And down here, I have the simple demonstration tool that you will be getting in your toolbox from Sue Ann. It's a strip of foam, and you might be getting a lovely pink. In one of the workshops, we had pink foam. I'm not sure what kind of foam Sue Ann has in store for you. It looks like she's going to get it, so it won't be a surprise. But this is boring gray foam to represent a mirror. Oh, there you go. You're going to get some nice white foam. The idea is to have it nice and dense and to use just some bamboo skewers, like for kebabs. And you glue them into the foam. Oh, there you go. And this represents the light and the mirror. If you have a mirror on the wall, those are generally nice flat mirrors. The light comes in bounces off the mirror and comes right back. So you end up with a relatively undistorted image. If, however, you are like the back of the spoon bent out like this, you can see how the light waves that come in get bent out, spreading you out, looking like that funhouse mirror. Telescope mirrors are curved in. Now, if you have kind of a wobbly mirror, not a very smooth surface, you're going to get kind of wacky images. But if you have a nice, well-ground mirror that has a great shape to it here, you end up with a nice, crisp image. Now, one of the things that you notice is that the light that comes in and hits the top is getting bent down and ends up at the bottom of the image that's formed over here. So this kind of a curved mirror, like your spoon, the inside of your spoon, or like a telescope mirror, will flip the image, will make things look upside down. Now, that's mostly important if you're looking at trees and birds and things on the earth. But when you're looking up in the sky, this inverted image isn't really so significant. So you don't have to worry about it being upside down or not for the most part with the kinds of astronomical images that you'll be taking. But this is a great little tool to explain how things get inverted, how your images get inverted. Now, another thing that we want to help you demonstrate is just how much of the sky you can see at any given time. And there's there was our little tool. How much of the sky can you see through the telescope? If you're using a backyard telescope, it often depends on the magnification, the kinds of eyepieces you have in. So first it's the curvature of the telescope that you're using, and then you might bump up the magnification and see even less. But the basic field of view of the telescope is something that is not so difficult to describe, except that we describe it with angular measure. You don't usually think in terms of angles when you think of the sizes of things, but we do when we're looking at the sky. So this is a common thing that we use just when you're outside, describing how far away things are from each other in the sky. You're looking at my belly there. I'll move this back up, sorry. You hold your hand out at arm's length, and you can use your pinky, and that will cover up more than the full moon. 3 fingers are 5 degrees, 25 degrees from thumb to finger. And this is the kind of thing that you would use to describe how far above the horizon something is. You could do a quick, rough measurement of how high something is in the sky. Or, oh, there's the moon and there's some bright thing over here. How far away is it? Use your hands to measure 25 degrees. Is it just 5 degrees? How close is it to something in the sky? But when you use binoculars or a telescope, you're seeing even less than that. And we've provided you with a tool. Whoops. Oh no, I gave away some of my pictures. Okay, there we go. On the web portal, on the Skynet Junior Scholars web portal, that is this thing which helps you figure out the field of view of the telescope. So this is a sheet of paper that you can print out, and I just used a pencil and went round and round and round on the edge of it to cut out these holes. And the holes represent, when you hold it at arm's length, a different field of view. So the top one is 1 degree. This is 30 arc minutes. So when you think of a degree, it's 180 degrees from horizon across the sky to the other horizon. 360 degrees all the way around, 180 this way, 90 degrees straight up and down, So 1 degree is, this represents 1 degree when you hold it at arm's length. And it's important to remember that the arm's length part of it, okay? Because this is not 1 degree when I'm holding it right up to my eye that I'm seeing through the hole, but what I see through the hole at arm's length is 1 degree. So what we want to do with this is get a feel for how much you're going to see with the different telescopes that are at your disposal with Skynet Junior Scholars. So one of the great points of comparison that we have is the moon. So the moon is about ½ a degree, 30 arc minutes. So which of these holes, well, here it's raining tonight, but if it weren't raining and you went out this evening to look for the moon, which of these could you see the moon through in its entirety, the whole moon?
Okay, so you guys have to speak up now and answer that question.
Oh, now I'm in control. Anna, what am I supposed to do here?
I think you're muted.
Can you hear me?
Muted.
So now I can, now I'm unmuted. You're muted still, Anna.
Okay, I'm unmuting everybody. I guess I have to do this one at a time. So anybody who's unmuted and not one of our ringers, one of our presenters, would you like to speak up? Which of these holes could you view the entire moon through?
Second from the top.
Okay, so that one is 30 arc minutes, so the moon would fit in that one. You could also see it through the bigger one then. If you can see it through this one, you could also see it through that one. Could you see it through any of these other holes?
Not the whole
one.
Not the whole thing. Okay, so this hole, it's surprising to me, I don't know if it was to you, just how tiny that little hole is that the whole moon could fit into. Did anyone expect that?
That is tiny.
I mean, it's tiny. You see these pictures of the moon, and especially when you see it like on the horizon, you get these images of this giant golden moon. And if you hold your just your pinky out, you can cover that giant golden moon with your pinky. If you hold up this card, you can fit that full moon, even the supermoon, in that little hole. So I encourage you to give it a try because it's one of the most surprising results to me when I think about things that you see in the sky. So the moon, whether it's up high when you think of it as looking smaller or on the horizon where it's this weird processing that your brain does that makes it seem bigger, you can cover it up with your pinky on the horizon. When it's up high, you could even fit it in this little hole here. So that's the moon as a point of comparison. And just in this next slide, I have 3 images of the moon with another celestial object. So whether it's on the horizon, whether it's up high in the sky, it's the same size. And here we have it in comparison to the Andromeda Galaxy. Now the Andromeda Galaxy is the closest spiral galaxy to us. And if you're in good dark skies, you can even see it naked eye as a little smudge in the sky. But what I rarely realize, because I've seen it with I've seen it naked eye, I've seen it with binoculars, and when you see it in a telescope, I didn't realize that it's actually 3 degrees across the sky. That's 6 full moons could fit across the diameter of the apparent diameter of the Andromeda Galaxy. That's huge in the sky. And so when you look at these different celestial images that your kids might have seen, or you may have seen online, some of these fabulous Hubble pictures, they always crop them kind of close. They don't have a lot of black space around it, and so you don't really have a sense of how big they are compared to each other in a telescope. And that's the little activity that I want to do in the next couple of minutes. On the flip side, on one side of your card there's directions, and on the other side there is the field of view of each of the Skynet telescopes. And you can see that it's a pretty wide range. We left the Hubble Space Telescope on there just to show you that it's tiny. You actually need to use a little push pin to make that hole. And then the prompt telescopes are 10 minutes of arc. There's prompt 2 is 21, and Yerkes is also 10. So that's halfway between these two holes, between this 15 and the 5. So it's a relatively small part of the sky that you see with any given image that you take, and certainly you couldn't see the whole of the Andromeda Galaxy. You'd have to do a whole mosaic to try to map out the entire Andromeda with the prompt telescopes. But let's take a look at some of these other things. I was going to say that the moon was a poor example because it's a forbidden object, and just before I started this, we started this telecon, I got an email from Vivian saying that it's actually not. If you use an exposure length of 0.04 of a second, you can. This was using one of the prompt scopes, SS04, with filter B. This was a full image. So we don't have time, especially because we got a little bit of a late start, to try to figure out where this image is on this full moon. I think it's along here, where those mare are. But you can see that it's just a fraction of the moon that you get with those telescopes. So if you've seen pictures, we already shared in the last web chat a picture of the whirlpool and of the sombrero. And to give you an idea of which telescope to use when photographing these, when imaging these objects, I wanted to give you some hints as to what to expect. Will the whirlpool fill your image? We've already seen one picture of that, and it pretty much did. And that's confirmed down here if you look at the apparent dimensions. I just took these off of Wikipedia. Wikipedia is not always the best source, but for these kinds of Messier objects, they have a really nice summary on the side of each Wikipedia page. And you look for the apparent dimensions, and they're given in minutes of arc, minutes or seconds of arc over here. So that's minutes. So it's 11.2 by 6.9. So 11.2 means it's just beyond the Yerkes or the prompt 1345 telescopes, because that has a 10-minute field of view. So this will fill your field of view with the whirlpool. What about the sombrero? Which telescope could you use to completely image that?
Show us a picture of your card again.
Oh, sorry. That's right. People don't have these necessarily, do you?
No.
Sorry. Oh, you know what? Rather than that, let me.
There we go.
Go back here.
Perfect. Okay, so that sombrero was about 8 arc minutes. Is that right?
Right.
I have no short-term memory today. So the question is, tell us.
Yep, I still have folks unmuted, so go ahead. Which telescope could you use? The sombrero apparent dimensions were 8.7 by 3.5.
The year keys or prompts?
Yep. So with a year keys or a prompt, you would get, it would almost fill the field of view, right? Going across, you'd have just a little bit of room on the sides there. And if you used one of these, prompt 2 or Dolomiti, it would take up much less of the frame. And M13 is one of my favorites. It's a globular cluster in Hercules. And again, it's one that you can see naked eye if you have really nice dark skies. And it says its apparent dimensions are 20 arc minutes. So it's a globular cluster, so it looks like a big fuzzy cotton ball. So 20 in any direction because it's pretty spherical. So, so if you use the prompt, one of these, prompt 1, 3, 4, 5, what would you see?
Prompt 2.
Right. So she said prompt.
You'd only see half of it, right? But with prompt 2, it would fill that whole frame. So you would just be looking at the center of it with the other ones, depending on how good the pointing is, the pointing accuracy of the scopes. You wouldn't see it in its entirety. Then I included 2 other objects here that are, the wild duck is just kind of a sentimental favorite of mine. When I first was learning my way around the sky and learning to star hop with a telescope and with binoculars, the wild duck cluster is one that I found. That I learned very quickly right off of Aquila the eagle in the summertime. And you can see its apparent dimensions are actually pretty big. It's 14 minutes. So even that little cluster, this image here is taken with a pretty wide field of view with our prompt scopes. At 14, it would more than fill the field of view with the year keys or the prompt 1, 3, 4, 5. Again, you would need prompt 2 or the Dolomiti or DSO 17 to get it in its entirety.
So I'll mention here that this card in its present form doesn't have the Australian telescopes listed because they weren't built at the time we made this card in the summertime.
Right.
So that could be a little homework assignment for somebody to find out what the field of view is of the Australian ones, SSO, prompt SSO telescope, and tell us that so we'll all know.
Yep. So when I just brought these up because when you or your scholars get excited about some amazing object that you've seen and you remember this, stunning kind of Hubble image that might have very well was probably a mosaic or other beautiful examples of astrophotography, that particular picture doesn't really give you a clue as to what the angular diameter is. So you might want to do a little bit of homework to find out what the angular or apparent dimensions are to see which would be the best telescope to use when you go to take a picture of it. And I think I'll just wrap it up there that this card is something that you can download from the portal, from the web portal.
And I will post a link to that in our forum.
Okay. And it's something that you can use as you're just kind of looking around the sky and starting to get used to it, thinking about your angular measures that you can use with your hands, thinking about how much of the sky you can see at any given time. And it gives you a really interesting perspective on just how much of the sky those things take up when you're taking the image of them. It gives you a little more human connection to it.
Susie, can I ask a question?
Sure.
Are Are the specifications on the CCD cameras themselves pretty much the same for all of the telescopes that we can use?
That's a technical question that I don't know the answer to. Vivian might.
Right.
I'm guessing they probably are, but I was just curious.
No, actually not. So
okay.
That's one of the reasons that some of the telescopes have a larger field of view, because the chip inside the CCD is actually larger. So there is a Skynet telescopes link on the Skynet page. I'm not sure. We're also switching Skynet interfaces, but that information is available, and the information is in the image header, but it's a little bit complex. It could be complex to understand. But for example, DSO 17 has a much larger chip than DSO 14 does. So you're right, the size of the chip inside the CCD camera has a lot to do with that, in combination with the focal length of the telescope, determines your field of view.
Yeah, and I guess kind of what I'm leading to, and kind of a follow-up to that, can we kind of assume, I know they're not directly related necessarily, but can we kind of assume that if a telescope has a smaller field of view, we're also getting higher magnification?
No.
Okay.
No, because magnification is all about focal length.
Right.
And then the field of view is a combination of focal length and the size of the chip.
Okay, so that might be the case, but not necessarily.
Right, right.
Okay, great, thank you.
And I think in a way there, Tom, you've asked an investigatable question. I mean, you could do an experiment to take an image of an object with multiple telescopes, everything else being the same, and see what you get. That would be a fun collection of pictures to share with people.
Yeah, that's a good idea.
Right, and thank you, Sue-Ann, for turning that into an inquiry. We did actually contemplate a field of view activity, and in the summertime, all of our telescopes basically had the same field of view, but then as we moved into the fall and different telescopes came online, there is really a difference. So I would like, one way you could compare objects would maybe be taking the same image with RCOP and with the Prompt telescopes in Australia. They're both in Australia, so that might be fun.
Great, and that's probably maybe a good point to transition. I think that was the last discussion you wanted to get to, was investigatable questions, but before that we had to go over the exposure time, so why don't we move on to that. I was able to talk to the support, and I think I've got our technical issues figured out. So Catherine, Sue-Ann, Susie, and I are all organizers. So Catherine, I think you want to share your screen, and so you should be able to click on your own name and make yourself presenter. Try that out.
Catherine, are you talking to me?
Yeah, you should be able to.
Okay.
You should be able to write.
I just changed presenter to Catherine.
Oh, great. Okay, so there you go.
Great.
So Catherine and Sue-Ann, if you want to take it away with the exposure time, go for it.
Well, this was just, again, another an exploration to get you to start to investigate features of the telescopes and what happens to an image if you change the exposure time. So in the exploration itself on Skynet Junior Scholars, it was fairly well guided, right? It was a guided exploration that sort of stepped you through the idea that if you're going to investigate exposure time, you need to keep everything else pretty much the same. And so I'd like to know, just first of all, as a matter of you guys being the first people to really try these out, if you found the Skynet Junior Scholars investigation clear. If you have suggestions for improvement of it, you can speak up at any time during this web chat and tell us about it. Did anybody go through this as it was intended?
This is Sayana. Can you hear me?
Yeah.
So I love taking pictures with a regular camera, and I thought it was very interesting that actually the less time that we put on there, the better the picture turned out sometimes. Like, I thought it would be the more time on there that it would be more grainy, but the less time it was more grainy, which I don't know if anyone else noticed that, but that was my observation, and I thought that was awesome.
Cool. How about other people?
And I guess, you know, it would depend on what you're taking a picture of and which telescope, but I found almost the opposite. I was using the prompt SSO1 for all of my pictures, and I was shooting M64, M74, and M83, which are all galaxies, but then also M46. And I tried exposures on each of those with the same telescope of 15, 30, 45, and 60. And at least for those small collection of objects, those 4 objects, I found the 60-second exposure to be the best in all 4 cases.
Tom, did you ask a question on the forum about stars versus gas? Was that you or somebody else?
That was not me.
Okay. Is anybody on the web chat with us that wants to admit to asking that great question? Time for stars.
It's a good question, but it wasn't mine.
We'll have to go back and look if you don't fess up here. Okay, so let's see. Dawn, were you first? Did you speak up first about the less time for you was less grainy?
It was James Pointer who asked about the finding the happy medium when you're sure to get bright stars and less bright objects.
James looks like so I'm going to unmute him. He's probably, oh, he hasn't entered his PIN. James, if you can hear me, there's a little pin that goes with your thing. So I hope you can hear us, but we can't hear you because you haven't entered that. But anyway, James, that was a great question. And he took some exposure time. Some seemed better for the stars in his image, and some seemed better for the gas that was associated with something else in his image. And he was asking about a happy medium there. So I think that, Catherine's going to open up a couple images that might pertain to that question there. So she's going to go to Open Files. Images. This will work. Yeah, it does now. That's awesome. And who are you picking, Catherine? Sailor Moon.
Yep. And then the M42 seemed to be a good example with these. I just want to open this one and
Who is Sailor Moon? They're beautiful. Raise your hand if you that is your handle on Skynet, Sailor Moon.
Or you can just speak up because everyone's unmuted.
Oh, it's me, Meg.
Yeah.
Oh, great. That's Meg Gower.
Oh, it's Meg's image? Meg's images?
Yep.
They are beautiful.
They are. So Meg, you're able to speak up, right? Your phone doesn't look like it looks like it's working. So
it's working. I just have a bad cold, so I didn't want to be
I don't think we'll catch
disrupting people.
Tell us about these.
So I found the same thing, that the less exposure time gave a better image because I saw more of the nebula, and the longer the exposure those bright stars were just overpowering everything. So the one that you're seeing on, well, it's on the left-hand side of my screen, was I think just a 2-second exposure, really short. And I wish I'd done 1 second.
Wow, those are short.
So I think it's interesting that you're saying that you like the gas and dust in the left image more in the one that has a shorter exposure time, because I actually like it more in the right image. I think I see more detail through here with like the wispiness of the clouds. But that's true that, the bleeding over from these bright stars is sort of drowning out what's happening on this part of the cloud.
So, Vivian, the question was asked, and we don't have to say too much about it, but the question was asked, how do you get both? How do you get a picture that gives you good detail in the gas stuff and doesn't overexpose on the stars? What do you have to say about that?
Well, I think you have to do exactly what Meg did, and look at these different exposure times. If your object, if you go back to, if you would have gone back to the wiki pages that were shown earlier by Susie, you'll also see something called magnitude, and we haven't spoken about that yet, but how bright are these objects? And M42 is a really bright object, so Meg, you did a good job at trying a really short exposure time. And that really short exposure time allows you to, to see detail but not get oversaturated stars. Now, if you would try doing the histogram window on both of these and setting it, you might be able to see more of the dust and the gas in that image with the oversaturated stars. So, yeah, so maybe even go down to like 98.5. Or, just make those numbers a little bit smaller, and then you'll see how you can see more of the gas. So it's all about how are we stretching this picture.
Try the one that, try the other one, Catherine. Let's look at it. Because it's not a little tiny bit. You've got little spikes on one of the stars there, but it's much less. We actually make it. Yeah. I agree that I must say it's less grainy on the gas and the dust, but the stars are better in the left one. So I think what the Hubble Space Telescope might do, or what other scientists might do, is take multiple pictures at very short exposure times and then try to add them together later, so they can control for the stars and still add light for the gas and the dust there.
Another technique that you can use is some of these stars are bright in some filters and not others. Now, M42 is just like plain bright all the way across the board. But in some cases, you can actually filter out the bright stuff and get the gases by what filters you use. So
that's fun.
And the idea of actually adding multiple pictures together is definitely a technique that's used in astronomy. We don't have that feature in Afterglow, so I didn't bring it up, but it's one of the ones that we want to add to our wish list when we work on improving Afterglow later this year.
So we, as part of this activity, Vivian presented another investigatable question, which I think will be coming up next with the filter activity. So maybe you can continue with some of the same objects that you're observing and see if you can obtain an image that does better for you, stars and gas and dust, by using different filters. So that's another investigatable question. So the other goal for this activity was to allow you to play around with a new tool, which is the photometer tool. And I'm wondering if people have anything to say about that. We'll have Catherine use it with a star or two. So on whatever window happens to be white, that's the active window. And if you click on the bullseye, the row of icons there, the double bullseye, you'll get some numbers in there. And so magnitude is one of them. So if you click on a star that appears to be dimmer than the one that you've just done, you'll notice that it's at the top, so it's really weird. You can change the order there, but 001 is the second star she clicked on, and you can see that the magnitude is a bigger number, even though the star appears to be dimmer. So if we click on the other one and you do the same stars, the other image, and do the same stars over there, finding those. Then you can start to look back and forth between your two images and see how the flux of each of these stars changes. So flux is just a word that means how much light we have picked up. So it's in other programs you might hear it called count. So brightness count or flux unit, either one, that's the same thing. So the greater the number of units, the more light hit that part of the CCD chip. So I've been playing around with this a little bit today as well, just to see if these flux numbers double if you double the exposure time. And did anybody play around with these numbers at all? And if so, what did you learn?
I was playing around with it and trying to see what happened if I took pictures of like 1 second, 5 seconds, 10 seconds, 30 seconds, and then see if, well, you know, double your exposure time. Did that double your brightness measurement? And it certainly seems to. It seemed like perfectly linear, like a perfect straight line connecting all of those.
That's really great. You've just hit on this amazing coincidence that everything turned out exactly perfect. But yeah, roughly it does anyway. Can anybody think of things, and Vivian, you can chime in here too, of reasons why you might not get an exact doubling if you double your exposure time?
I'll wait to hear from some other people first.
Okay. I'm going to look at this one. Let's take a look at this one that's up right here. Pull up the calculator.
I'm guessing if you get something that's so saturated because it's sort of overexposed, there's going to be a limit to how much light the photometer can actually count. Is that correct?
So once you've hit the little CCD detector's limit, once you've saturated it, that's all she wrote?
Yeah, that's what I'm wondering.
You know, that is exactly true, although you do get some of that bleeding going out in either direction, but the limit for most of these chips is 65535 counts in any pixel place on the CCD, any one of those detectors. And so if you go over that, then you're not going to get any more dynamic range out of that part, out of that star. And if you're actually going to be wanting to do some science with that star, you want to keep it from becoming saturated. So in Meg's picture, if she was trying to study some of these stars, she wouldn't be able to study the ones where she used the longer exposure, but she could study ones where she used a shorter exposure, and those spikes definitely mean it's overexposed. But it can be overexposed even if there aren't spikes. So another tool that we want to incorporate in Afterglow is to be able to see how many counts are in each pixel as you move your mouse around.
So, and any other reasons why you might not get a direct comparison with doubling your exposure time and seeing a doubling in your flux unit. Did anybody get? I keep turning around. I'm sorry about that. My phone's behind me. My speakerphone's behind me. Did anybody take their different exposures on different nights, or did you get them all on the same night within a little bit of time of each other?
I used my first light image from last week, and
all right.
James Pointer is having some audio issues, but he said that he did different nights.
Okay. And can James tell us if he had a nice linear response between doubling exposure?
He says there was not much difference between my figures.
So
I think what
again is a good question to continue to investigate. Of course, we encourage kids not to stop the first time if they get the results they desire, but to make sure that they repeat the experiment and see if it holds water if they do it more than one time. So great. Did anybody have any issues with this activity?
The only issue I had, everything went perfectly on the activity, and then today, so I didn't get my images back until recently, and I had trouble uploading them. I tried several different computers, and I don't know what I'm doing wrong. But other than that, everything went beautifully.
In other words,
them to the gallery or to
exactly. Afterglow was perfectly fine, and I was able to do all of the studies on that. It was just uploading it into my gallery.
And who is talking? Who's
Sorry,
talking?
this is Jen from West Virginia.
Okay, all right, Jen. I'll look into that. Are you using the ID number? Maybe Catherine, you could go back to a Skynet page and show that ID number.
Oh, I know what you're talking about with the ID number, that sort of the value that they give you when you're in Afterglow in the little file. Is that,
right.
because that could be my issue. Maybe that's what I'm doing wrong.
Actually, you take the ID number from on the Skynet page itself, and in this image that Catherine is showing,
right.
next to the picture it says ID, and you don't want the 0 or the dash. You just want all those digits right there, and that's the number that you upload when you're going to upload from Skynet and they ask for the ID.
Okay, and the last time I did it from my computer, when I did my first image,
right,
and just browsed my computer, and I was having trouble that way too. Does that still require the ID, or does that matter? Is that just a browse?
You should be able to upload from your computer.
Okay.
So
I was having trouble with that, but I know for the other one, you're right. I don't think I used the proper ID for inside of the program.
Right. We know that's confusing, and we've asked for a change in how that's presented, so it'll be more clear. But thank you for bringing that up, because I'm sure that was a problem for other people besides yourself.
So I just want to do a quick time check. It is the top of the hour, and we know that some people will need to leave. We're happy to stick around for a while to answer some more questions. And I'd like to propose that we move the discussion of investigatable questions into the forum. But we'll mention it briefly here. So we're going to stick around for a while and answer questions. But if you need to leave, all signs point to the recording working. So you'll be able to go back and review it. I'll post it as soon as it's ready to go in that AFCU forum. So thanks everyone for joining us. Apologies for the technical difficulties at the start of the chat that got us started a little bit late. And now we can take more questions.
Be thinking of questions you'd like to investigate. We're going to ask you to come up to list some investigatable questions on the forum. Thinking of them. All right.
Any other questions?
can I ask a question? This is Kathy Gustafson.
Please.
I cannot even get into Afterglow because I cannot download any images from Skynet. And I have tried a couple different programs, and I have had my tech guy here at school try to download also. And he's actually sent me to sites to get different things to expand the files, and I cannot get any images downloaded. So does anybody have any suggestions at all? I have a PC, not a PC, excuse me, a Mac.
Kathy, first of all, you don't download the images to use them in Afterglow. So we'll talk about downloading in a minute, but Afterglow happens if, Catherine, you'll go back to Skynet. So if go back to my observations. Oops, sorry. And yes, you're on my observations there. And you click on any one of these objects that's in your my observations area. There is a little button up at the top on the right that says Afterglow. So you can either click on that and go there, or you can just remember the URL that's up at the top right here, which doesn't have, you don't put any HTTP or HTTPS, because this is not an HTTPS site, I don't think. So if you just type in skynet.unc.edu/afterglow and click in your username box and log in, then you'll be able to open your image from right inside here.
Okay, I see. Okay, that part I didn't try the little Afterglow button on the Skynet image. Okay.
So what you did when you downloaded the images is that you got them in a zip folder on your desktop when you downloaded them, and that does enable you to open them with. You first have to unzip them, and then you can open them with any other image processing program that you might have, like Hands-on Universe or DS9 or
yeah, that was the problem. It wasn't unzipping, so that's good that I can just download it to Afterglow, or I mean, just click on that Afterglow button.
Yeah, so try that. And but we'll try to figure out the Mac issue with the zip files. I don't know what Mac uses to unzip a zip file.
Kathy?
Yes.
Okay, so if you go to one of your observations, and let's see, if I write something, are you, yeah, okay, are these Kathy's? Well, it doesn't matter.
These are mine.
Okay, so you see on the side where it says fits reduced or fits, okay, so if you like hold down, I don't know, Control, Option, Command, one of those, or you just click on it, it will give you the option to download it. Let me just try it here, and you know how you can remember, your fingers remember. If you just hold down Control and click on the FITS file, it'll give you a save link as, and then it'll download that particular FITS file. So you don't have to download the zipped file. And then the other thing, if you do download the zipped file, you use the terminal window and you unzip and you put the name of the file in there. So I can show you that later, or I'm not an organizer today, so I can't share my screen with how to do that. But
I'll try that Afterglow first.
Okay.
You know, the button up at the top where it says Options. I'll try that first, and then I'll let you know if I'm still having trouble with that. Because I have to do it at home, because that was the other issue, is that our school is having troubles with the security of the Skynet site. Our server will not even show me a quick look at any of these images.
Okay. So we're also dealing with that, those certificates. So we'll put that on a high priority that gets done.
Okay, thank you.
Okay, those were really good questions, and I know that on the Skynet site itself, it has frequently asked questions, and we need to start populating that link so that those questions can get answered.
Good idea.
Thank you for bringing both of those up.
Okay.
Oh, do you see what just happened?
I do see what happened. The frequently asked questions is broken right now.
Right. That's what I'm saying. There's nothing there, but we have to write something. So we'll get on. We'll work on that.
Any other questions?
You can't. The other thing we would like you to do is, you see, under FAQs, there's report a problem. So if we want you to use that button like crazy. Anything that is frustrating you, you don't understand, you think is a problem, go ahead and fill that. Fill that out, because that goes right to a smart sheet, and all of us plus the Skynet developer sees those issues, and we put them on a list of things that need to be addressed. So that'd be really helpful for us if you report any problem you notice. And don't worry about how formal you're saying it. The only thing I would say is maybe put your name after it so we know who to. I'm not sure that we can tell who the problem came from if you don't write your name down.
And you do get an answer.
Good.
Thank you, Vivian.
Yeah.
All right, any other questions?
Is there anybody on the list? We've been trying to keep track and see who's gotten the images, but it's a little awkward from our point of view because we have to actually open every observation to look. So I would like to know who, wants some hand-holding in order to get their first request in, or who is frustrated because they've tried to take an image and they haven't gotten anything back. Let's hear about problems like that, because we want you to be successful. We could just kind of do a roll call and
I don't think it's anyone who's on the chat right now, but I have that list going. Feel free to speak up if you are on the chat and are having those issues.
Is Sailor Moon still on?
I think that was Meg.
Yeah, Meg, are you still there?
Yes.
Okay, so Meg, I noticed that you, in your Saturn picture, that it seemed to be saturated when you brought it up in Afterglow. Did you try it?
I did, and it didn't look good in anything, so I couldn't figure out what I had done wrong.
Well, you didn't do anything wrong, but, and then someone had taken an image of Jupiter for 15 seconds before we had limits in. So all these bright planets, just like the moon, you have to do really, 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 really short exposures.
Oh, okay.
So, like, a half a second or 5/100ths of a second, 0.05. That'll allow you to see rings and things like that. So give that a try. Is that Sailor Moon's there? No, yes. This is one that's not saturated, right?
Ooh, I want to get this tooled off.
Oh no, actually.
This must be a bug.
Yeah. And then.
Oh wait, no.
Yeah, and then this one probably was the telescope jiggling in the wind or something. So you can sort of see a disc there, but there's nothing you can do about the telescope not jiggling. Pick a different telescope, maybe.
This is like Galileo's image where he thought this object had ears.
Right. But it's fine to post to the forum if you're puzzled by an image and you don't know, you're not quite, you think it might not look the way you thought it should look, and you want to know, you want to get some discussion going about why it appears that way.
All right, great. I'm going to suggest that we wrap it up now. Unless there's any burning questions, feel free to speak up as I'm wrapping up. But just to let everyone know what to look for, I will get that we were going to have a discussion on investigatable questions, and I'll get that thread started in the forum. I'll also be posting the recording of this chat as soon as it's ready, along with links to various resources that came up during the discussion. there'll be an end-of-week survey like there was last week, which will go up today or tomorrow, and that'll be just quick 5 minutes. It really helps us know how the workshop's going for you. And I'll also post a message looking ahead to what we'll be working on next week if you want to get a head start. And we're going to start looking at filters next week. So if you want to get a head start requesting relevant images over the weekend, you'll be able to do that. So that's what you should look for today and tomorrow. And thanks so much, everyone, for joining us. And apologies for those technical difficulties, but it looks like we figured it out. If Sue-Ann, Catherine, Vivian, if you have any closing remarks to say, please feel free. But thanks, everyone, for joining us.
Thank you.
Thanks, bye, everybody.
And if you want to stick around for a couple minutes, we can check in after once everyone's signed off.